What are we doing today? Don't ask. Hey, what's up guys, my name is Cherno. Welcome to Code Review series in which I review your code, except today I'm reviewing my code from 10 years ago. Yes, we're going to be taking a look at the very first game I have ever made. And by game, I mean something that I made from start to finish and actually, publish. In fact, publishing aside, just making a game from start to finish, like a final finished product, this is it. This is the first one I ever made. This was all the way back in high school in 2012. It was my final year of high school. I was meant to be studying for my final exams. Ludum Dare 24 came around, and I was like, you know what? Just make a game. Did I know how to make games? Was I a good programmer? Did I have any experience? No, of course not. I mean, I was kind of teaching game programming at the time on YouTube as I was learning it, so I had that going for me. But this was kind of possibly not a very responsible decision. Again, going back to the fact that I was supposed to be studying for my final high school exams. But aside from that, it was a good way for me to kind of challenge myself and actually try and make something. And Ludum Dare, which for those of you who don't know, is like a game programming competition in which you have 48 hours or 72 hours to make a game from scratch. This was the compo variant of Ludum Dare, which meant I had 48 hours to make a game myself. I think from memory, I spent 1 day doing it instead of 2 days because I, again, had to study for the aforementioned exams. So today, we're going to sit down and we're going to actually go through the code of the first game that I ever wrote, and we're going to probably criticize it a lot, but hopefully it will be somewhat helpful to some people who are maybe also learning programming if I can kind of, point out my mistakes, and we'll probably just have a laugh. Have a laugh at it, really, is what this is about. Because Merry Christmas, everybody. Happy holidays. Hope you're all having a great holiday season. That's why I'm wearing this somewhat festive shirt. I thought we'd have a little bit of fun, at the end of the year and just look through this thing. So I will actually have the code linked in the description below. It is pushed to GitHub. It says 6 years ago. I don't actually know why. So there's 2 commits 6 years ago. I don't know why this is 6 years ago. Maybe I changed GitHub accounts or something. I have no idea why this is 6 years ago, to be completely honest. I think maybe I just didn't have a GitHub account back then. Yeah, that's probably it. I probably didn't have a GitHub account back then, and I probably provided the source code, because you have to provide the source code if you're doing the compo, as just a zip download, and then eventually I was like, I know what Git is now. Let me just publish it to Git. Don't you just love it when it says initial commit instead of initial commit? Yeah, sign of quality there. Now, Ludum Dare was a bit annoying and took down all of their data from the original pages, but thanks to the power of web.archive.org, we can actually see what that page looked like. So this is a snapshot from 2014, which is, not quite from, the date that this actually happened, but it's still the page. You can see my beautiful old logo over here. And yeah, this is the game. My first Ludum Dare game was made in about 20 hours as I'm finishing my last year of school, and had sacks, that's what they were called, man, to finish in hand in the next day. Absolutely beautiful decision by me. Let's make games. Came 280 overall, which is not bad. I think there was 1,500 entries. So all things considered, not bad. And yeah, I don't know. Some people seem to like it. So yeah. Did I mention the game was written in Java? I don't think I did. But yeah, I was basically learning programming at the time. I was inspired by Notch. Not just because of Minecraft, although everyone basically in high school was playing it back then. I was really interested in graphics, and I wanted to learn how to write a 3D renderer. And so I was kind of trying to learn programming myself. High school didn't really teach it. We just learned I don't know, HTML, that kind of stuff. And so since Minecraft was so popular at the time, I was following Notch, seeing what he was doing. And he actually did quite a few live streams where he just made games from scratch for Ludum Dare. And that was just such a huge inspiration, because he made a game from start to finish. And it was all the footage was there. And that was something so new to me because, instead of following some weird tutorial online, it was here's a live stream. Here's starting from scratch, from no lines of code at all. And then at the end of it, you get a finished game, and it's within a manageable time frame. It's within 48 hours. So it's not like a game that he made over months that I would never be able to basically replicate. It was it was a small kind of scope, which was really, really helpful and super inspiring. And so following along with his code, trying to learn from it, and then also I think I had a Java for Dummies book or something that I bought, or probably convinced my parents to buy, that I was also kind of using to try and learn the language. And so eventually I did kind of pick it up, and I was able to write all of this, I guess, from scratch within, you know, the 48 hours. And a lot of it is kind of inspired by Notch and like, I guess, how he wrote code as well. So there's probably a bunch of stuff here that doesn't make sense. Like, for example, public synchronized void start. I think like why did I use that keyword? Probably because I'd noticed he did that, for example, for his like start and stop functions, I think in the main class, which if I recall correctly, were like called by applets, and there was something to do with some threading model here as well. And I didn't quite understand that, but I was like, okay, whatever, he's doing that, I'll do that as well. So I guess it's interesting. I've probably only ever talked about this like once. I made a video in like a forest in the Czech Republic called How I Started Programming. And I think that video I go into depth about how that happens. So if you guys are interested in that, then check it out. I'll link it up there. But you know what? Before we dive into this, I just want to thank Brilliant for sponsoring this video. Brilliant have been an amazing sponsor for like the last 6 months or so. And if you've been watching my channel, then you know how much I love Brilliant. And the reason why is pretty simple. It's because it's really good. Any sponsor I work with on my channel is because I really believe in their product and I think it can help you guys. Or it's something that I use personally. And for Brilliant, it's both, because Brilliant is an amazing online learning platform with lots and lots of really high quality courses on various STEM topics. It's really useful for all of you guys learning computer science and programming. They have so many math courses that can help you make games such as this one. And it's not just simple stuff like this everyday math course that you can start with if you're just getting into math. They've also got some advanced stuff like calculus, which I have personally gone through those courses to revise calculus because it's been a while. The reason why I specifically like Brilliant is because their courses are really visual and interactive. They have these widgets you can play with. They will quiz you on the content that they're teaching you to make sure that you retain the information and learn effectively and also in a fun way. And that's really important. And the best thing is you can just try it for free. You don't have to pay anything. Just go to brilliant.org/thecherno and check it out. See what they have to offer. And if you do like it and want to continue using it, Brilliant have been nice enough to offer the first 200 of my subscribers 20% off an annual membership. So definitely check it out. They've been a fantastic sponsor on my channel and they just have a really good product. Thank you, Brilliant, for sponsoring this video. So let's play the game. I'm just going to hit play, and here we have Genesis, a game by Cherno, which would be me. Now, if we hit play, I won't bother you with the other menus. Basically, the point of this game is to like essentially reproduce with all of these women that you find on the island to create, I guess, babies. And what that really does is it increases your population count. So you just go around having sex is basically the game. Now, why did I come up with this idea? Now, I will tell you it was a hit in high school. Everyone loved this. Everyone loved this game in high school when we were like passing it around. But why? Oh, that's a lot. 4. I think 4 is the max you can do. Now, okay, a few notes before you guys get too carried away. You will only ever like give birth, I guess, to male babies. So, in other words, all of these women, none of them are your daughters. Thankfully, they are all, one's stuck in a tree. They are all not related to you. That is how it goes. And also additionally, you can see they have like a little tag on them that goes red once you've already reproduced with them. So you can't like, you know, keep going. You can't just keep, you know, mating with the same woman over and over again. So this is, this guy's quite a character. You know, he's just like, once is enough, you know, with any given woman on this entire island. There are, I think, 3 maps that I kind of designed for this, and they were all designed as like images, like in paint.net or something, where every pixel is a tile. I was struggling to find women here, you know, too real. So, hopefully my wife doesn't watch this video. And so there's also like this timer down here, so you only have 5 minutes to execute all of your actions, all of your deeds. And yeah, the idea is just to get the highest population number you can, and you do that by just reproducing with more and more women here. And this just sounds so ridiculous saying it out loud. Always love talking about this game. There's no correlation between like, you know, the visuals and what you see here. This just will increase, and the rate at which that increases is dependent on how many of these collisions you've had. And there's also like a day-night cycle, as you can see. It's getting like darker, which is pretty cool. I don't know why I just threw that in there. I don't even know exactly how that works, but it works. And yeah, and so really this just comes down to getting lucky, I guess, with finding these women on the island. Because what happens is when you do reproduce, since that woman like has already, that female actually, the code refers to them as females. When that female has been, you know, how do I say used up, but like in a better way. This is the festive spirit. Here we go. So like, because that obviously happens and that female has been, cannot be used again, there has to be like, you know, some other new females appearing. And the way that works is they just randomly spawn in somewhere on the island. And I think the amount of them, see, I'm finding like a lot now. The amount of them that spawn in kind of also depend on you know, how efficient you are with your reproduction. And so you can see we're getting quite a lot here, and the population now is like skyrocketing, which is good. That's what we want. It's becoming a little bit more of like a let's play, but I'm sure you guys get the idea of the game. And you can see some of them like remain lit, even though they shouldn't because they're not in the light. That's just like a little lighting bug I threw in there. Anyway, I'm not gonna play out the rest of the 2 minutes. You guys get the picture. Okay, so taking a look at the code, how did it all work? Well, we have this like game.java file. There's actually quite a lot of stuff going on here. And I believe that I didn't hear any music working. I think the reason why there's no music working is because it used to use like applet new audio clip. I checked this out just before I recorded this video, and there was no music. And there's no music because I think it used to use some clearly deprecated functions, because again, this was like 10 years ago. I don't even think applets are a thing anymore, and that's why that's not working. Performance is pretty good, like 1,500 FPS. I don't think there was a limit on like the frames, on how many frames per second it renders. Like, it doesn't stick to your refresh rate or whatever, but it does only update the game 60 times per second. And all of that, I believe, is set up basically in this run function. So what happens is basically this. The game starts up, there's the main function in Java. We create a new instance of this class, which is called game, and then we set like the frame to new JFrame. I don't know why this is all done in the main function and not in the constructor. I suspect there's no real reason for that. Like, the constructor does actually do things as well, but I don't know why I did it this way. Again, possibly just Notch did it similarly to this, and I just copied that essentially. So that's where that style probably came from. And then basically what we do is we add, so the game class itself is a canvas. It extends canvas, which is like a GUI element. And you can add that canvas element to the frame. So we create a new JFrame, which is like a window in Java, and then we add a canvas element, which is what this class is. And being a canvas element, it can draw things, like it can render graphics, and it also implements runnable. And the reason why that, I can't believe I remember all this, but the reason why that is a thing is because if you implement runnable, the runnable interface just has a run function. So it's like an interface. So if you're familiar with C++, that would just be like a pure virtual function. And so you have a pure virtual function called run, which we have to implement as part of this interface. And the reason why that's a thing is because if you have a runnable, you can basically create a thread. And like in like C++, you know, you'd create a thread and you'd pass a function into the constructor. Now in Java, and I might be wrong here, but in Java, at least back then, like this is before lambdas. This was Java 1.6, I believe. And so this was before lambdas were introduced into the language. And so I'm pretty sure you could not tie a function into, like, you couldn't use a function as a variable. Like, that was just physically not possible. And so what you had to do instead is you basically had to create a whole new class with an interface, and then that interface would mean that you would have to implement a function. So you create a new class, you implement a specific function, and then you pass that whole class instance into like some API that requires it. And that way, it would be able to call your custom function. So in other words, it worked in the same way as like a lambda or a function pointer, but it had to be wrapped in a class because you could only pass classes. And that's why when we create the thread here inside the start function, which I believe the applet automatically called, because again, this was in fact embedded in a web browser as well, this game. It wasn't just a desktop executable like you saw there. It was also, I believe, something that I could embed into a web browser, because back then, applets were still a thing. And so because of that, we had like, I think, start and stop, because those have to exist, or in some variant of them, I think, have to exist. Is there an applet? Nah, maybe not. Game applet. Yeah, there is. So game applet, you can see extends applet, and I believe that has to, applet itself had like a start stop, and I just kind of, you know, delegated that to game.start and game.stop. And so that's why that design comes from as well. But you can see it creates a new thread, and it passes in this, because this implements runnable, which is why we can pass that in. And what that will do when you call thread.start is call the run function. So that's why that happened. And also, like, why am I creating an extra thread to run the game on instead of just running it on the main thread? I believe that's something to do with applets, but I just remember that's something that Notch used to do. And again, I think that's maybe it's because of applets, maybe it's a stylistic thing, but when I first learned this stuff, that was kind of just what I thought you had to do that, and there you go. So now we have the whole game running on a separate thread to the main thread, and that's why I believe in stop, we have like thread.join as well to make sure we wait. You know, running gets set to false. Running is a member variable. Would be fantastic. Like you can see, I didn't use like any kind of convention here, m underscore like pixels or anything like that. It was just straight names because again, that's I guess what Notch did. But also, you know, the Java books I read did that as well. And also like the m underscore convention is just something I picked up at EA. Like that was not something that I used at all prior to that, even like university and stuff. I think university in C++, like the lecturer did have a convention, but it wasn't like, I think it was like, you know, if you were passing something into a function, you know, like you'd have a p like for parameter like that or something out the front of it versus like, anyway, something like that. But basically, yeah, the whole game happens here. You can see there are some like literal timers here to determine whether or not we should update it. That's why it only gets 60 updates per second. So there's literally just a timer running and that's how we decide. There's no like vsync or anything. And then if system milliseconds like minus last time greater than 1,000, so it's in milliseconds, meaning if we reach 1,000 milliseconds, so 1 second passes, we increment it by 1 second so that we get to the next second and we print out like this and we do a level update timer. So basically this block here only runs once per second. And so there's some very manual timing going on here, which again is something that games do nowadays as well, but it's just interesting seeing it kind of all laid out like this. And then yeah, the update function will kind of update the input, which will basically, so you can see the input handler class just has all the controls kind of hard-coded here. And in the update function, we just see whether or not this massive boolean of keys, 65536, which is like just a 16-bit value basically, because maybe the key codes can't go above that. I don't know why, but whatever. The key code, like what we have here is just a boolean array where we just have every single key, I guess, that is currently well, its state. So if it's false, it's not pressed. If it's true, it's pressed, which again is a bit ridiculous to just allocate like an array like that, just so that we can basically store every key at its index. And then like when we lose focus, yeah, that's the other thing. I think if I click somewhere else, you can see it says click to focus. So I did like a little focus listener as well, so that we could basically, where's like the terminate button? Here it is. So that we could, you know, make sure that we released like all of the keys if we lose focus. And then also if the game wasn't focused, you have the click to focus, which again, I remember Notch did that as well. And the reason why he did that was because I think sometimes if the game's embedded in a web browser, like as an applet, you know, you might have the page focused, but not the applet. And so you have to click on it. And so that way, you know, just in case you like booted up a page and we're reading through like, you know, how to play the game or whatever, and you were like, oh, why are the controls not working? It's because the applet wasn't actually focused. And so I think that's why that's there. But yeah, so that's kind of how all of that works. And then we have, okay, so what happens, and this is like some really interesting programming going on here. Oh man, some of this is coming back to me. Okay, so this play menu biome, this is kind of funny. So when you're learning programming, again, like everyone's experience is probably a little bit different, but I remember one of the things that I really struggled with was like, how do I link two things together? If I have this game class here, right, and I know that, for example, I have inside the update function, like I want to say load a different level based on what is picked in the main menu. The main menu, you know, correctly so, contains all of the stuff related to the main menu. So if I have like, you know, a play button, and let's just say someone either selects a specific level, or in this case, I believe you can't select a level, it just randomly assigns you with a level. If the main menu is the thing making the decision of which level we play, so for example, like, I guess, you know, index 2 or like ID 2, then how do I communicate that to the game so that the game knows which level to load? Because the main menu doesn't really load the level. You know, the game should do that. And I just remember struggling with this stuff so much. So what I would kind of do as like a little, you know, inexperienced programmer trying to make this stuff work is a lot of the times I would just make the variable say static, because that means that obviously if the variable's static, it's kind of global and I can just access it in any class that I need it. Now, from a design point of view, you know, this isn't the best thing to do, but it definitely worked. And you can see over here, what I've kind of done is I've just accessed like the play menu's biome to see what it has been selected to, what its value is, so that I can do the appropriate thing. And you can see here as well that if play menu biome equals 2, then we basically create a new instance of this ocean level, which is a specific like level, I guess. Ocean level, you can see, just loads like ocean.png, but otherwise it's just a level. So I just decided for some reason to make, I guess, all of these class instances. So let's see where all of the levels are, I guess here. Yeah, there's like forest level, there's snow level. This is a little bit of a weird decision as well. I basically had all these classes which were like subclasses of this like superclass called level. But the only thing they did is they called a constructor of level, but with a specific like level file to load. So like, why would you do that? Why would you create an entire class just to set this piece of variable data, basically? It's either snow.png or forest.png. I think there's like island or something.png as well. Or maybe forest was like the name of the island. Well, anyway, the point is that's ridiculous, because what I could have done is just called like level with the path straight up from game, or even just had some kind of like array of levels. I guess like the way I would probably write this nowadays, if I had to, was I'd have like some kind of, like if the levels were hard coded like that into the game, I'd probably just have like an array of like 3 strings or something called levels. And then I haven't actually written Java code in years. I have no idea what the syntax is. But basically, I would just do this. Just Control Tab does not work. What was it? Snow and snow and ocean. I would just do something like that. And what that means is that if we come over here and we're trying to load a particular level, instead of trying to make an entire, instance of that specific class that I've written just to contain that string, essentially, you can just set level equal to new level with, the path being levels at whatever index biome you've selected, such as this one. And that one would, of course, correspond to that one. So this is probably what I would do these days. Again, back then I was probably like, ooh, arrays, like what do they do? I'm sure I understood arrays by this point, but my brain just, I guess, wasn't working kind of like it is now, which is understandable. This was 10 years ago, and I think this, like by then, by the time I made this game, I had probably about 1 year of experience. And experience is a very loose word here, because my experience was, again, like Java for Dummies, programming in all of my spare time, trying to learn this stuff, and watching like Notch's live streams. That was probably my entire experience. Like, I remember trying to go to people at school, in high school, and being like, hey, can you help me with this code? No one knew programming. Like, the IT subjects that were taught were like, PHP, databases, HTML mostly. Like, there was almost no one who actually understood like programming. And so it was kind of difficult for me. Things got better in university, but yeah, it was a little bit rough. But I got there in the end, didn't I? So there's always hope. So yeah, that's kind of funny. And then I guess we make a female. So I'm kind of skimming through this stuff, but I hope this is easy to follow. You play the game, you launch up the main menu, which I didn't really show because I don't know if that's worth showing. But basically the main menu is just a little bit horrific because there's all these like hard-coded variables. I think one of the things that was a problem I remember, was I basically responded to like key pressed, but it would just like, because the key would be pressed for longer than a frame, like you can't press a key that quickly. If you even held it down a little bit, it would just skip over to like, the next menu item. And I tried to delay that. And the way I delayed that is, because you can see it's kind of delayed if I hold it, it still goes. So it doesn't really, I don't have to let go of like the up arrow and then press it again to get to the next one. It just skims over it, but it does so slowly. And the reason why is because there's like literally a timer here that says, hey man, only like go into this branch if I'm trying to go down to the next menu item, if the time is at 0. And otherwise, if the timer is greater than 0, it will kind of decrement the timer. So that basically means that you can only advance to the next menu option after like 10 frames of having gone through one, because that resets it back to 10, if that makes sense. So that was my kind of strategy for delaying it, which is a little bit weird. I guess nowadays, like, I'm not sure if it would even be a problem, but if I had used events, for example, I could make sure that you basically have to, physically release the key and make sure it's pressed again, because if we only respond to key pressed events where we have a repeat count and that repeat count is 0 and we only actually kind of, dispatch the event or like handle the event, let's just say advance to the next menu option, if that repeat count is 0, that would have worked fine. And that's how I'd probably do it like in Hazel, these days. But back then, of course, I knew nothing about that. What are events? Like, that didn't really make sense. So that's why I had this kind of state of input keys, and I dealt with that. And then basically all it does is we have all these different menus, but otherwise, I think what it does is you can see, so if we do in fact press, I guess, the enter key, so this is all the rendering, then you can see that, okay, so what it used to do was it used to set the biome to a random integer, I guess, between 0 and 2 inclusive, but now it's hard-coded to 2 because I think even though I had different like biomes, I guess, different like maps, the only one that really played well was that island one, and so that's why that's the one that we saw here, and that's why I ended up hard coding that to 2, I guess, so that, to make sure that it actually played that. Even though like, so ocean is that one, right? Yeah, forest is different and snow is different. Yeah, so ocean is the one we played. That's the island one. So that's kind of interesting how that works. But I'm kind of skimming through this. But the point is that, we're in here update, biome number 2 has been selected. It's time for us to play. So again, everything is stemming from this game class, which is not really great. There's no like state machine. There's no like, what scene should I be rendering now? Here's a main menu scene. When I press enter, tell the scene manager or something to advance to the game scene. There's none of that. It all is just happening inside like this one game class, and there's basically just a real-time kind of in every update like function call, there is an if statement, there's a branch that says, what am I supposed to be doing? And in a way, this is working like a state machine because it's saying, if the biome is 2, load the level, but then obviously set the biome to -1 so that next frame we don't wind up loading the level again because we're now playing the level. So it's kind of interesting. And then if biome 0 is selected, that's the forest level. If biome 1 is selected, that's the snow level. Again, you can see there's like a bunch of code here that's kind of repeated-ish. This is like presumably... Okay, so this is us creating a new female, which is a mob, that has like I guess, a fixed spawn position or something, even though we're supposed to, I guess, randomize that. And then we add like the player to the level and we set its spawn point manually like that. And this is funny because it's happening all inside that update function, which is a bit of a disaster. You'd want to kind of do this in like a different place completely. And then obviously for that female as well, we set its spawn position. So basically, the map, this little island map that looks roughly like this or whatever, and then surrounded by like, water everywhere, it gets kind of loaded, and then the player gets set here, and then the female gets set there. So that way you kind of have that starting point, and that will always be the same. We have this population counter, I guess, which, oh no, this does more than count, doesn't it? Okay, so you can see it has a population count. You start with 2 because obviously you have the player and you have the female. And then the growth is kind of like, that's the rate at which it grows. And you can see the population here is just plus equals growth, and they're both doubles here. And so that will grow. And then, okay, so every 800 population, we'll actually add a new... Oh, okay, so that's why we were actually seeing more females appear. Oh, I forgot about this entirely. Because simply every 800 population... we will just spawn in for the ocean level a new ocean mob, which I guess, but is that going to be a female or not? Or is that just more and more? I think that might just be, oh, here we go. If level, but that's specifically for the forest level, which this isn't. I think this will just populate it with just normal mobs, basically, to just make it appear as if there's more population, because obviously it's growing. Yeah, that's probably why. Because obviously the number's getting so much higher, but we're not really seeing visually more and more people, so that's probably why that's there. And then, yeah, this class also will render all of that kind of population text. So that's kind of what happens there, but otherwise we just have level update, which will update all of the entities. So this part is kind of more or less correct and more or less what you would expect from like a normal game. We have like this class called level, which is like our kind of, it's like a scene. It's like the container for all of the entities inside there and all of the tiles which make up the game world. So we have a list of tiles. And a list in Java it's the same thing as like a list in C#, which is just like a resizable array of contiguous memory. And we have entity as well, which we just have all of our entities here. And so the player, all the mob is basically all of your entities, potentially like the torches as well, for those light tiles are there as well. And then we just have So we load the level from the file. That's where everything begins. And that's just us reading in the image file and basically going through getting every single color that we have in there and adding that all into this tiles array. And this tiles array is what determines, you know, basically, I think that's just like it's a one-dimensional array that just contains all of the tiles in our level. And you can see that there's this function called getTile, which basically you just give it a coordinate. If it's like out of bounds, it will kind of give you, I guess, the ice tile or a void tile, depending on some different parameters. Yeah, I guess if it's out of bounds, it'll give you a void tile unless it's the snow level, in which case it'll give you the ice tile. But basically, otherwise, you can see it will literally read the color value. So the reason why these numbers are so kind of big is because the levels, as I mentioned, I don't know if I can find them here. Levels, sure, ocean. Yeah, so you can see here that there's like, this is kind of low resolution, but we have all these colors here. And the different colors correspond to different tiles, right? So basically, we just read the value of the pixel, I guess, in that coordinate in the image essentially, but we've copied the image data into this tiles array to see like, hey, is this like the color? And there's FF here because the alpha channel is always going to be, you know, full alpha, and then it's like RGB or BGR, I don't know. But basically, based on that, we return the right tile, and that presumably is used inside like the render function here, which you can see goes through everything and yeah, and we'll just like render the appropriate tile. We do get tile, and then we do tile.render. And you can see as well that the way I've made this is instead of just physically drawing the pixels like a normal person, this is basically like a base class called tile. And then there's tile.render, which is a function implemented by all of these tiles. And this to me is madness. This is very interesting because this is such an object-oriented approach to programming, and this is basically just Notch's style of programming. Notch's style of programming was very object-oriented, like it would have been, because I'm pretty sure this is where I got this from. I mean, I'm sure that the books I read were also very object-oriented, but like I just remember Notch did it specifically this way, and he just loved this kind of stuff. And so he would basically have like, you know, a class for everything. You have like a specific stone tile which can override some certain functions, even something as simple as like public boolean solid. So is it, can you walk through it or can you not walk through it? That is like a function inside, like it's like a virtual function inside a subclass, inside a derived class that answers that question, right? And then you also have, you know, public void render, which is something you override that says how to render this tile. But again, the problem that I have with this these days, and it's interesting just how, again, object-oriented it really is, but the reason why this is kind of not how I would do things these days is because what it means is, like, just look how many classes you need. And I mean, Java programming is a lot like that, or at least back then it was. It was very much about classes because, as I mentioned, there were no lambdas back then. You know, you had to create classes if you wanted any kind of, like, function, you know, to pass in a function somewhere. But you can see that what this does is identical for like everything. I'm assuming this is false by default. It is. And so that's why you have certain things that are solid, like, you know, the, I don't know, is ice solid? Yes. Like, you know, ice and like stone, I think we had as well. All that stuff specifically returns true. But render tile is like the same, you know, maybe torch or like some of these are a bit different, but more or less it's the same. The other thing you might notice is we have this like left shift 4. Now, this is also influenced by Notch because he wrote this a lot. And the reason why, so for those of you who don't know, a bit shift left by 4, well, whenever you're really bit shifting left or right, what you're doing is you're either multiplying or dividing by 2 to the power of n, where n is this number here. So basically, shifting left by 4, what that's doing is that's simply taking x and it's multiplying it by 16, because 2 to the power of 4 is 16. That's what we're doing here. So this code could be rewritten as this. Now, why are we multiplying by 16? Because now we're trying to render pixels on the screen. And this gets passed in as a coordinate. So we have like, picture the level is just made up of like a grid of pixels. And we have a coordinate, you know, like 5, 5, where we want to like 5x, 5y, where we specifically want to like render, you know, our tile. Let's just say it's over here. So to actually figure out what pixel on our screen we need to start rendering from, we need to multiply it by 16 to kind of translate it or like transform it from that kind of, grid index space or grid coordinate space into pixel space. And so we multiply it by the size of each tile. And each tile was 16 by 16 pixels. That's why you're seeing this. Now, why was it written as a shift left 4 instead of times 16? Because I believe, well, again, because Notch did that. Why did he do that? I think something about this being faster, because a bit shift is faster than a multiply. But again, these are things that I would really expect the compiler to just do for you. If it sees that you're trying to multiply by a power of 2 and it's an integer, it should probably just convert that into being, a bit shift if that instruction is faster on the CPU it's running on. And because Java's all virtual machine based, it can probably just do that on the fly. But again, I don't know the intricate details of Java, nor do I really care. So let's move on. We'll go back to level and we'll see how the rest of the tiles are rendered. But basically, yeah, that's what happens. And that's why X scroll, here it's dividing by 16 to get from like this X scroll and Y scroll, which would be in pixel space, into like a grid coordinate over here as well. And that's kind of, I think what this is doing is based on the scroll, which is basically just the position of, well, this I believe, if we go back to game and just check out render for a second, I believe what this would be is basically, you can see X scroll is player X minus screen width divided by 2. So what that's doing is it's taking the player X, but then it's shifting it a bit so that we basically center this. So screen width divided by 2, screen height divided by 2, that's obviously going to be the center of the screen, but also we're offsetting it by the player X and Y to get like a level position, but centered. Well, kind of a level position, but shifted. And the reason why is because we basically want to say, okay, well, if the player's here, if we know that the player is over here, let's offset the player's X and Y by half the screen width and height so that we basically get, if we subtract and subtract, let's just say going up is subtracting, then we get this. And the reason why is because we then want to render from this space forward so that the player is nicely centered. And that's the X scroll and Y scroll we pass into level render. And that's kind of the offset of all the pixel coordinates. X0, X1, Y0, Y1, that's just determining the bounds. So we basically have the horizontal bounds. So from this X coordinate to this X coordinate, and the vertical bounds from like this Y coordinate. I think, positive Y was actually going down. So that would be like X, this would be like Y0, and then this would be like, Y1. So we've determined bounds, and everything within those bounds is going to basically get rendered. And again, we divide by 16 to get into that grid space, and I believe what that does, along with this little screen width plus 15, to make sure we also include a partial tile. So can't believe I remember all this. Well, it's not. I'm deducing a lot of it from the code I'm seeing, but a lot of it is from memory as well. So what this will do is basically, if we have a tile that's like, because obviously we're moving around the screen, you might have partial tiles in view. It's not like it's moving based on tiles. You can move smoothly between tiles. And so because of that, if we have something like that, I think what we're doing is we're adding 15 or whatever plus screen width, but also plus 15 to get us over the edge so that this actually does get included or something like that. And if we go plus 16, it will include like 2. So we're doing like the max value of, I guess, 1 or something. But then we also loop through that kind of view, and we retrieve the appropriate tiles and we render them. And again, that will just go to a class called screen. And the class called screen just contains the actual rendering. This is what actually sets pixels. And so what that will do is basically render tile. You can see, again, it does like some kind of offset because you can set an offset into screen, I believe, to offset. So that offset there, actually in level, was used just to get the index. So this is like a tile index offset. Now we have to offset the pixels as well. And that's what this kind of XP minus X offset is. This gets set by a function called like set offset. That much I remember. Here it is. And that again gets set from the main game class. And then we go through and you can see for the size of the sprite, we do some checks here to make sure we're in bounds basically, and also clip, which is, this is incorrect. You don't want to clip like this. So I had a break here, whereas I should have probably had a continue, and that's why we have to have this. But I don't know if you guys noticed, but you can see that up there. So this actually says that if it's out of bounds, just set it to 0 instead of like continuing. I believe if we had actually had a continue, and then I believe instead of like this, I don't know why this would be here, but instead of this, if we just maybe set this to like 0, so that if it's less than 0, it doesn't actually do anything. we probably would just get rid of that. Yeah, so you can see we fixed that bug rather easily. But I believe the reason why I didn't do that is because, remember guys, we're literally rendering every pixel one at a time here by setting a color into an array. And so because of that, I think what I had noticed was that if we break instead of continuing, like break is faster than continue. Why? Because break will abandon that entire for loop, whereas continue will just go to the next iteration and check again. And so I think because of that, I distinctly remember this. I was like, okay, break is faster, so let's just do break, and then we'll also like do, you know, this in here to make sure that we clip it and we don't crash, basically. So a bit of a weird solution, but sure. That's kind of what I had going on there. And then, yeah, we do some kind of, we have this class called Cherno color, because the color was already taken by Java. So I had a little Cherno color class, which did a bunch of like, you know, this is just it extracting all of the channels from the kind of integer color here and brightening them by a particular amount. Okay, so this is how the day-night cycle worked. We could tint it, I guess, a specific color by just adding that value to RGB, and then like, you know, clamping it basically. And then also we could change the brightness of something by just adding it. You can just add like to each channel, you just add the brightness, and that obviously makes the color brighter. So interesting. That was kind of cool to see. Haven't looked at that in a while. Yeah, well, anyway, this is kind of dragging on, but very interesting to look through a lot of this code. The rendering specifically is kind of interesting because it's not hardware accelerated at all. This is all kind of software rendering. We're literally setting pixels on the CPU here into like an array, and that pixels array, I believe, is what we eventually draw. Back in the game class, we have this like buffer strategy that we get from the canvas, because remember, this is kind of extending canvas, and so we get buffer strategy, and then that's like into the buffer strategies draw graphics. That's what we kind of use here to actually, I guess we pass that in so that we can do things like draw strings, because draw strings was drawn using Java's API, but all the tiles, all the mobs, they're all drawn pixel by pixel using this actual code here. So kind of in a way software rasterizing. It's not really rasterizing because there are no triangles, it's just pixels. But yeah, that's kind of cool. Kind of miss doing things that way. And then you can see at the end, this is how we actually draw it. So we that pixels is actually tied, that pixels array is tied to an image, which we then copy, by the way, here. So we actually set pixels I equal to screen pixels I. This is a redundant step that I would remove. Why have this copying of the whole buffer of pixels over here if you can just presumably just access this pixels array, because you can see this pixels array is image. So this actually comes from image get raster get data buffer get data. That's what gives us that array of pixels, that if we like whatever we write into here, that is tied to the image that we then draw over here. So instead of doing that, like you could literally probably just set screen.pixels equal to this same thing, and that way when you write into it from the screen class, it's actually writing into this memory. Again, something I'm sure I didn't understand back then, but that would prevent this kind of, essentially it's like a mem copy of the whole buffer. That would probably be an optimization, I would expect. And then the other thing I believe I could do is width and height, you can see, is actually 300, and then also width divided by a 16:10 aspect ratio to get the height, right? And the scale is 3. What that means is that when we actually launch this is a 900 wide window, not 300, because we multiply it by 3. But we render to an image that's kind of, 3 times smaller. It's only 300 by, whatever that is. And so actually we can probably hover over this and see it. Yeah, 300 by 180. And that obviously speeds it up because we're rendering less pixels, and then we're just kind of upsampling it or scaling it up without filtering, presumably, by eventually drawing the image at get width and height, which is the resolution of the canvas, because get width and get height would be, from the component, which a canvas is a component. So that's kind of an interesting way to create both a pixelated look, because everything is kind of lower resolution, then scaled up, but also improve the performance like dramatically, essentially. Because I believe if we just, set this to 1 and made this 900, of course we're pushing way more pixels now. And you can see it's a little bit weird, but you can see a lot more of the island actually, but you can see it's down from like 1500, 1700 FPS to like 400. Still not bad, but remember back in 2012, with whatever lower spec computer I had back then, but also, 10 years ago, computers in general were slower. This would maybe not even have run at 60. So, yeah, it's kind of interesting. But yeah, that low resolution look, I guess, was also part of the aesthetic that I presumably wanted to have in this game. Yeah, I mean, that's it. To be honest, like, I mean, yeah, there's a lot of really weird decisions, lots of like hard-coded numbers, lots of like stuff being not in the right place, not knowing how to, tie classes together. I don't know if it's worth me kind of demonstrating how I would fix these things. I just feel like, to me, a lot of these are so elemental that I feel like you guys just don't need help with that. And it's like, it's understandable. Like, you can see the problems, but maybe that's just me, like with my current experience, obviously looking at this, looking at young Cherno here. I was but 17 when I wrote this code, looking at this stuff and just being like, what is this kid like doing? Like, obviously this is not how you do certain things. And so a lot of these mistakes are kind of, I guess, obvious, but maybe they're just obvious to me. So if you guys want me to like show how I would fix some of these things, how I would create better relationships, then drop a comment below, let me know. But otherwise, thank you guys for watching this code review. There's still like probably quite a lot of stuff I would go into. I mean, to be honest, to be fair, we have like calculated quite a bit. I didn't really talk about like there were supposed to be predator mobs that tried to kill you, but I think I cut that feature. You can see there's even health and stuff in the code base, but I believe that just got cut because it's Ludum Dare and I just didn't have time to do all of that stuff. We've covered most of the stuff. The AI kind of for those, like, I guess, females, so the way they move is actually random. Like, it's just random. I think what happens is basically, we just like we have a random integer, out of 40. And if it's 0, so there's like a 1 in 40 chance of hitting this branch basically every frame, it will just pick a random direction to move in. So basically, we might pick up as a random direction. So the mob's moving up, and then a 1 in 40 chance for it to be like, oh, actually go left now. And that's it. And so it's just completely random, like the entire movement, which, is a bit weird, but that's easy Ludum Dare AI. Just make it move, make it randomly change direction every now and then, and you basically get something that more or less, seems like it has a life of its own, which is, it's that easy. Anyway, thank you guys for watching. I hope you have a really good festive period. I hope you've all had a really good year, and just take a break, relax, soak in the festivities. Check out Brilliant using my link in the description below, and I will see you guys later. Love you all. Goodbye.